Hey guys, welcome back to geometry. Last couple times we were together, we were talking about angles. We talked about naming them, we talked about measuring them. This time we're going to talk about comparing them. Specifically, we're going to talk about something called congruent angles. Now, back when we talked about segments, we said that congruent segments were segments that had the same length. Well, congruent angles, guys, are pretty much the same thing, but they're angles. They're angles that have the same measure. Okay? Now, the way that we would write this is we would say angle ABC is congruent to angle X, Y, Z. So we have this symbol, the same one we used with segments. It's an equal sign with that little squiggly on top. Okay, and that means congruent, which means that those two angles have the same measure. Then we have this thing called an angle bisector. Well, when we talked about segments, we had a segment bisector. An angle bisector is pretty much the same thing. It's a ray, line, or segment that divides an angle into two congruent angles. So, if I have a diagram, maybe it looks something like this. Okay, and I have angle A, B, C. And then I have this ray in the middle going through this point D. If I say that D bisects this angle, that means it separates it into two congruent angles. And the same way we had some shorthand notation with segments, we would draw the little tick to show that segments are congruent. We put those little red arcs inside of an angle to show that two angles are congruent. So in the past, you probably drew those arcs in every single angle that you drew. Now we want to keep in mind that those arcs indicate that these two angles are congruent. So what we could say about this diagram is that angle ABD is congruent to angle DBC, which means that those two angles have the same measure. So the measure of angle ABD is equal to the measure of angle DBC. So looking at this example here, we have ray PQ bisects angle RPS. So what that means for us is that the angle that we started with was angle RPS, but PQ bisects it. So that means that this angle and this angle are going to be congruent. So we can say angle RPQ is congruent to angle QPS, which means that the measures of those two angles are congruent. The measures of those two angles are equal. Now, if we have congruent angles with equal measures, we can use that along with some algebra to find some missing variables. So, in this example, they tell us that CB and CD are opposite rays. So CB and CD form a straight angle, meaning 180 degrees. Next, they tell us that CE, that's this ray, bisects angle DCF. Okay, so we start with angle DCF, and we have ray CE bisecting it, which means these two angles are going to be congruent. Then they tell us that ray CG, that's this one, bisects angle FCB. So that means that these two angles are also congruent. Now notice, the first two angles I put a single arc into those angles, showing that they are congruent. These two angles I put a double arc, which shows that they are congruent. We want the difference between those two so that we're not trying to suggest that all four of them are congruent to one another. Just the first pair and the second pair. Now, in part A, they tell us that the measure of angle DCE, okay, so tell you what, I'm going to highlight this. Angle DCE, that's this guy. They give us a 4x plus 15, and then they tell us about angle ECF. So ECF is this angle. Now, based on our diagram, because CE bisects angle DCF, we know that those two angles are congruent. So we can start with that. We can say angle DCE is congruent to angle ECF. Now, because those angles are congruent, that allows us to say that their measures are equal. So angle DCE equals the measure of angle ECF. Now, guys, once we have that set up, we now have the makings of an algebraic equation. Because I have the measure of angle DCE is 4x plus 15. So I can put 4x plus 15 in place of the measure of that angle. And in place of the measure of angle ECF, I can put 6x minus 5. Now we've got an algebraic equation that we can solve. Okay? Both sides are pretty well simplified, but I have x's on both sides. So I'm going to subtract 4 x's from each side to move all of my x's over to the right. And I have now 15 equals 2x minus 5. Okay, so now we'll add 5 to both sides. And we'll have that 20 equals 2x. We'll divide both sides by 2. And we'll get that 10 equals x. Now, keep in mind, guys, we want to pay close attention to what the directions ask. Because they didn't ask us to find x, they asked us to find the measure of angle DCE. So once I have that x equals 10, I need to take that and sub that into the measure of angle DCE, which is this. So now we can say the measure of angle DCE equals 4 times 10 plus 15. Well, 4 times 10 is 40, plus 15 is 55 degrees. So the measure of angle DCE is 55 degrees. Okay, we use the fact that those angles are congruent to build an equation. We solve that equation, and then we use the value of x to answer the original question. Okay, let's take a look at another one, very similar. Okay, this very similar question, in fact, uses the exact same diagram with all the same descriptions. So we still have that these two angles up here are congruent because the angle BCF is bisected by ray CG. We have ray CE is bisecting angle DCF, so we have that these two angles are congruent. Now this time they're talking about angle FCG, which we said is this guy. And then we have the measure of angle GCB, which is this guy. So it's two different angles, but it's the same scenario as last time. We have two angles that we know to be congruent. So let's start by saying that those two angles are congruent. Let's say angle FCG is congruent to angle GCB. Now, once we have that the angles are congruent, then we can say that the measures of those angles are equal. So angle FCG is equal to the measure of angle GCB. Now, same as last time, we have expressions for each of those angles. So in place of angle FCG, I can put 8x plus 3. And in place of the measure of angle GCB, I can put 9x minus 2. And now we've got pretty much the same thing we had last time. We need to get that variable by itself. We've got x's on both sides. So I'm going to start by subtracting 8x from both sides. Okay, 8x minus 8x is 0, so I just have 3. 9x minus 8x is 1x, or simply x. Minus 2. Add 2 to both sides of the equation, and we'll get, that's not what we wanted, x equals 5, or 5 equals x. There we go. 5 equals x. Okay. All right. Now, we take that 5 and we sub it into the original equation. So if I want to find the measure of angle GCB, that's this guy, I'll take 5 and I'll sub it in place of x in this expression. So 9 times 5 minus 2. 9 times 5 is 45. 45 minus 2 is 43. So that means that the measure of angle GCB is 43 degrees. All right, so if we have that angles are congruent, that means that their measures are the same. We can use that to make determinations about the diagram. We can also use it with some algebra to solve some equations. All right, guys, this is the last video for this section. You can find your worksheet or your assignment on Canvas. This video is posted through Canvas. If you have any questions at all, feel free to contact me one way or another to get those questions answered. All right, guys, I look forward to hearing from you.